Question 11. Use the binomial expansions to show that the root of 1 add 4x all over 1 minus x is approximately equal to 1 add 5 over 2x minus 5/8 of x squared. So looking at this, we can say that our starting root here can be written as 1 add 4x to the half multiplied by 1 minus x to the negative a half. And we can expand these two separately. So I'm going to start off by looking at 1 add 4x to the half here. And so using our formula, we get 1 add n, which is a half, lots of ax, which is 4x, add n, which is a half, n minus 1 minus a half, ax squared, so 4x squared, all over 2 factorial. So this is going to give us 1 add 2x, and then we've got a half times minus half is minus a quarter, times by 4x squared. So this is minus a quarter times by 16, which is 4 over 2x squared. So we got that part. Second part, 1 minus x to the negative a half. We expand this, it's going to be 1 add n minus a half, ax minus x, add n minus a half, n minus 1 minus 3 over 2, ax squared, all over 2 factorial. So we've got 1 add x over 2, and then here we've got x squared is positive, minus 3 over 2 times minus half is positive, so we're going to have add 3x squared, and we're going to have over 2 for 8. And then we remember that we're multiplying these together, so we've got 1 add 2x minus 2x squared times 1 add x over 2 add 3x squared over 8. Remember, we only want to go up to x squared here, so when we multiply out, we're going to get 1 add x over 2, add 3x squared over 8, add 2x, add x squared, minus 2x squared when we multiply these out. Anything else is going to give us a power above 2 for x. So simplifying this, 1 add 5x over 2 minus 5x squared over 8, and we've shown exactly what we needed to do there. Part B, student substitutes x equals a half into both sides of the approximation shown in part A in an attempt to find the approximation to root 6. Give a reason why the student should not use x is equal to a half. So for part B, if we look at our validity tests, then we can easily see this and pick up the mark that we need. So if we look at the first one, we say 1 add 4x is equal to 0. So 4x is minus 1, x is minus a quarter, and so therefore x has to be, modulus of x is less than a quarter. So as a half is greater than a quarter, x is not valid. That's why we can't use it. For part C, substitute x equals an 11th into that to obtain an approximation for root x. Give your answers of fraction in its simplest form. So our first substitution is going to be 1 add 4 lots of an 11th over 1 minus an 11th. And so that will give us root 3 over 2. Now subbing that into our actual value, we can say our expansion, that is approximately equal to 1 add 5 lots of 1 over 11 over 2 minus 5 lots of 1 over 11 squared over 8. So we can say here that root 3 over 2 is approximately equal to 1183 over 968. And so if we simplify this, so we've got root 3 over root 2 and we want to rationalise the denominator, this becomes root 6 over 2. It's approximately equal to 1183 over 968. And so therefore root 6 is approximately equal to 1183 over 484.